Welcome to Mr. Getz's flipped classroom. Today is a little bit different. I'm standing in front of the board in the classroom. What I have for you today is the new unit that we're starting, and we started working with ratios. And one of the problems that we've been looking at here, a baseball player hit 5 out of 22 pitches, write a ratio that shows balls he did not hit to total pitches. Now, I'm going to do the definitions here first so we can see the definitions. Now, a ratio is going to compare two quantities. Ratio is going to compare two things. A quantity is an amount of something, right? So comparing two amounts of something. A ratio not only compares a part to a whole, which is all we've been doing. So we've been doing a lot with fractions, we've been doing a lot with decimals, percentages, and what we've always done was part to whole. How much of the whole thing do we have? But also we're looking now at part to part. It's gonna be a little bit different. Now, let's go back to it over here. So examining question 1 from the bell work, gonna go back a little bit here, back to the baseball player. So typically what we would do with this is we'd be like, okay, hit 5 out of 22 pitches, let's see what percentage the person hit. Well, this is asking something a little bit different. A ratio that shows balls he did not hit. If there were 22 pitches and he hit 5, 22 minus 5 is 17. 17 pitches were not hit. And then we're going to be comparing that to total pitches. Total pitches is 22. The answer is going to be 17 to 22. Another way you could write this, 17 to 22, or 17/22, or 17 over 22. Just like that. Let's see what else we got here. Couple different scenarios, and in these scenarios, we're going to be comparing parts and wholes. Let's take the first one. A restaurant got a big order for 12 bacon and egg tacos and 18 chorizo tacos. What I recommend on these problems is so we don't get lost with the numbers and what means what. Bacon, tocino, y huevo. We got bacon and egg, and there's going to be 12 of those. And then we're also going to do chorizo. And then on chorizo, we're going to do 18 of those. So if you were to set this up like that, if the question said, give me a ratio that shows bacon and egg to chorizo, you're done. Now, what if the question said, give me bacon and egg to total tacos? Right? We already know that the bacon and egg from the problem is 12. We got 12. What are the total tacos? This is everything in the world. This is the only thing that we're given. We got 12 bacon and egg and 18 chorizo tacos. Do we multiply? Subtract? No, we're going to add them. We're going to add them. So let's do 12 plus 18 is going to be 30, and that's going to be bacon and egg to total tacos. Very nice. What else do we have? Let's do problem number 2. Problem number 2. When Molly got home from the store, she checked her dozen eggs and found 3 eggs cracked. 3 eggs cracked. Let's do cracked eggs to total eggs. As I've been looking at this with my students, there's 2 ways we can go with this. We can overcomplicate it and be confused and not really understand it. Or the other way that I see students going, Mr. Getz, this is easy. Stop talking about this. This is easy, right? So I'd like my students to see it as being easy, right? Cracked eggs to total eggs. We had 3 eggs that were cracked. A cracked egg is still an egg. How many total? There were a dozen eggs. So for the dozen eggs, that's going to be 12. Cracked eggs to total eggs is going to be 3 to 12, just like that. All right, what else do we got here? Looking at one with a football example. So a quarterback threw 22 passes, he completed 50. How many passes did he complete? There are 22 passes he threw, completed 50 of them. What is half of 22? Well, it's going to be 11. So there were 11 passes that were completed. So if we were to do completed to total, completed 11 through 22. Or you can say 11 to 22, or you can say 11 over 22. Just like that. You could also go in and reduce it. Yes, he completed 50%. If you reduce 11 over 22, that's going to give you 1 over 2. That's going to give you a half right there. Let's see what else we got here. Going to do one more with you. One more. This one we looked at a lot in class this week. And this one's got a neat part in it where you actually go from decimal to percentage. So the question says, the little squares indicate recipes used in each picture. I had students say, what does indicate mean? Well, the little squares show the recipe. The little squares represent the recipe in picture A and picture B. A yellow square is a cup of lemonade. 1 cup of lemonade. We have up here our key or the legend that says what's happening in this world. And I really want students to look at problems as this is what is given. This is the world. There's no other information that we're using to solve this, right? We really have to look at what is given to us. A yellow square is a cup of lemonade concentrate, and a blue square is a cup of water. Which picture will have the stronger lemon flavor, or will they be the same? Well, I've had students come up to the board, they took the marker, they went ahead and wrote on it. Let's look over here. So let's do a ratio of lemon to water. We want to write it out like that. Lemon to water, 1, 2 lemon, 2 lemon to how many water? 1, 2, 3, 3 water. Same thing over here. Let's do lemon to water again. And we have 1, 2, 3, 3, 2, 1, 2, 3, 4. Now looking at this, it's a little bit difficult to say, oh, this one has more lemon. This one has 3, this one has 2. Well, wait. Yes, this one does have more lemon, but it also has more water. We need to do another calculation here. Let's do lemon to total liquid. Lemon to total. How many are here total? Five. And we know our lemon's 2. What do we have over here? How many? 1, 2, 3, 4, 5, 6, 7. 7 total. And we know we have 3. 3 to 7. Now can we tell 2 over 5 compared to 3 over 7? Which one has more lemon as the part of the whole? A little bit hard to see. But what if we converted these to decimals? Convert to decimals. Let's say 2 over 5 is equal to, this is one of those benchmark ones that I encourage students to know, to memorize, right? So this is actually going to be 0.4. We could run the calculation on it. I'm not going to do that now, but I will run the calculation on the next one. 3 over 7 is equal to what? Let's go ahead and divide this out. How many times does 7 go into 3? This is division. 3, 7, 0.0 over here, get our decimal points. We want to make sure we're following our decimal points. What times 7 is a little less than 30? Let's count by 7s. 7, 14, 21, 28, 35. Ooh, that 28 sounds good. So that 28 was 4 times 7 is 28, minus 2, bring down the 0. Yes, bring down the 0. And then what times 7 is approximately equal to 20, or a little bit less than 20? Let's go with 2. 2 times 7 is 14. Subtract 6. And then we're going to bring down another 0 because there could be another 0 here. You just go 3.000 as much as you want to, right? So what times 7 is a little less than 60? This is always a tough one to memorize. 8 times 7 is so hard to memorize lots of times. 8 times 7 is going to equal 56. So we're done here. What if we go to round this? Let's take that 0.428 and say, hey, this is 0.43. This is still a little bit hard to see. So what we're saying here is the first one is 0.4 lemon. The second one is 0.43 lemon. Which is greater? We've already done greater than, less than, or equal to. 4.3 is greater. I'll show you one last thing. What if I were to say the first one is 40% lemon, the second was 43% lemon. Second one is 43% lemon. Oh, that's got more lemon. That's got more lemon. Which pitcher will have the stronger lemon flavor, or will they be the same? This pitcher, pitcher B, is going to have the stronger lemon flavor. Thank you for spending some time with me in Mr. Getz's Flipped Classroom. Have a great day.